this today because I'm going over the same problems. Okay. So there is my I think that's a pretty good color inside the lines. Look at there. The first for everything. All right, so there is the blue area. So what is the area of a rectangle? Area of a rectangle is equal to what?
1.
No, area of a rectangle. Tell me the formula for the area of a rectangle.
Is it base times height?
Base times height. We don't know the area. That's what we're trying to find. So we leave that right here. The base is 10. And the height is what? 1/30. I don't know why that's my son. He knows I'm in class.
Could be an emergency.
What?
And maybe it's an emergency.
No. Hold on. Yes, sir. You know I'm in class. Is it an emergency or what? Good. Okay. Love you. Bye-bye. Oh, I forgot. 10/30, which is equal to 1/3, which is equal to 0.333. So this area between these 10 and 20, that's 0.3333, or 0.33 probability, or 33% chance of being between 10 and 20 minutes late. Okay, so now we're going to do the second part. We'll do it in orange because we really don't have anything to do on the chart. We're going to change this 20% into 0.2000. That's 4 digits. So what is that? Is that an area or is that a z-score?
Z-score.
What did I tell you 4 digits were? Four decimal points.
4 decimal points are...
Should be in your notes from Friday.
It's probability.
Probability or area, yes. So I'm going over here. Let me draw a line between my part A and part B. Okay, so I'm going to go over here and I'm going to put area of a rectangle is equal to base times height. And we've got 0.2000 is equal to base times 1/30. So divide by 1/30. Divide by 1/30. And of course that goes out. So B is equal to, and watch how I do this on the calculator. I just type it in exactly like it looks. Let me clear. Anybody watch Bar Rescue this weekend? No. 0.2000 divided by parentheses 1/30. See, I typed it in just like it looks. I didn't do any shortcuts. I didn't do any multiply by the denominator. I just typed in 0.2000 divided by 1/30, and that is equal to 6 minutes. So B says that the person shows up 6 minutes late and they meet at 10 o'clock. So the person will show up by what?
10:06.
10:06. So this is 0.333. And the second part is 6 minutes. And you feel good about yourself. Next, any questions on that?
Can I see part B, how you got 0.2000
There you go.
divided by? So 0.2000 equals the
It's equal
base.
to base times the height.
Okay.
All right, so let's do nerd. Next one is 7.115/6. 17.115. I'm sorry, 7.1. 7.115/6.
Hubert, I have a quick question real quick.
Uh-huh.
So is this next exam on units or chapter 6.1, 6.2, 7.1, and 7.2?
Yeah.
Okay, I just want to make sure. Thank you.
All right, so we've got 0 to 30. Got a uniform distribution. Since the base is 30, the height is 1/30. And that's 5, 10, 15, 20, 25. And they want to know the probability of at least 20 minutes late. Now, this question, it comes out to be the same as the first question, but it's a little bit different. What does at least 20 minutes late mean? That means the lowest number is what? 20. So I'm going to draw a line at 20, and I'm going to do it in blue. And somebody tell me, since the lowest is 20, how do I show that numbers are greater than 20?
Do the greater than sign?
What numbers are greater than 20? How do I show that?
25.
Make
Do I
greater
shade
than
the right
sign?
side or the left side?
The right side.
The right side. So I need this area right here.
Why you need that side?
Because it says at least 20. At least 20 means the lowest number is what?
Oh, 20.
20. So if the lowest number is 20,
Mm-hmm.
that means you're shading the what? The right-hand side.
Okay.
So now, the probability of at least 20 is the area of a rectangle is equal to base, which is 10 times 1/30. And this one turns out to be just like the previous question, except it's a little bit different. So that's equal to 10/30, which is equal to 0.3333.
Hubert, how
Yes.
come it says the base is 10? Isn't the base the line on the bottom?
Yeah. What's the base of that blue rectangle? What's the base of the blue rectangle?
20.
How many feet, how many minutes is between 20 and 30?
10.
There you go.
So that's why that's okay.
Yeah, you go with the base of just look at it. What is the base of that blue rectangle? 20 minutes. 20 to 30, I mean, sorry, 10. 30 minus 20 is 10 minutes. And let's go back to our question. And type in 0.333. Free. Nothing is free. Next question, 7.1, and I got this question 3 times. So 7.1, 35, 15. 7.1, 35, 15. 7.1, 35, 15. Now, the first thing I'm going to do is I'm going to pull out my handy dandy curve because I'm going to draw a picture on my curve. As soon as I can find one. And here we are. Why am I going to draw a curve? Because what does the first line of this problem say? Mean is what?
I can't see it.
266. And the standard deviation is what?
16.
16. So when a question says the mean is equal to 266 and the standard deviation is equal to 16, that basically says draw the what? The curve. That's what it says. I don't care what the directions say, you're going to draw that curve. So 266. I had that thing somewhere because I didn't feel like drawing it. Where is it? There it is. $266, $282, $298, $314, $250, $234, and $218. And I'm going to take my red marker and I'm going to color this area because we know that is unusual. And we know this side is unusual. And we know the middle is green, but I'm not going to color it because it's too busy. Okay, so we're done now. Now let's go back to the question and see what it says. I'll give everybody a minute or two. Finish writing that problem. And I would tell you to draw 2 of them. So let's go ahead and draw another one while we're at it. Of course, this goes against the lazy attitude disorders. But I can tell you right now, if you try to do these problems in 7.2 without doing a picture, you might as well just go ahead and just leave it blank. 266, 282, 298, and 314, 250, 234, and 218. All right. And I'll go ahead and while y'all are still, I'm trying to give y'all enough time to draw them. Because I know how devious some of y'all are. All right, so here we go. First question says, the first question says, provide, okay, the area to the right of 280, the area, the probability of 280 or more is 0.1908, or the probability of at least 280 is 0.1908. B says,
I can't see your board.
well, I got to write it down first. Hold on.
I like to see you write.
Okay. Okay, so there is this is A. So I'm going to go to my handy dandy and I'm going to find 280. And I'm going to do 280 in yellow, just like the video. Where is 280? Well, 280 is right about here. So I'm going to take my handy dandy and I'm going to draw a line right there. And I'm going to highlight which side. If it says at least 280, what does that mean? That means the lowest number is 280. So which side am I going to shade?
The right side.
Right side.
Right side. Now, what does this mean? This means that if you give birth there is a 19.08% chance that your birth will be at 280 days or more. Because this area right here, what was it, 0.1908? Let me look. Yeah, 1908. So I'm going to take my black marker. This yellow area is 0.1908. So you've got a 19.08% chance of your baby being born over 280 days. 280 days or more. That's what that means. Okay. Now, I did go over this in the video, and the question didn't ask for it. But somebody tell me, how many sides are there to 280? How many sides are there to 280? We've got one side in yellow. That's the right side. What's the other side?
It's
That's
less
this
than
side. It's this side over here. Less than 280. I'm going to color that blue, because that's also called the what? Starts with a C.
Complement.
Complement.
The complement.
Now, the question is not asking this, but I'm going to include this because I did it in the video, because I didn't read the question right. I thought it was talking about the complement, and I went ahead and did the complement, so I'm going to do it here. The complement, there's two sides to a number. This 280, there's two sides. There's the right side, which they asked for, and then there's the left side, which is the blue side, and that is called less than 280. So somebody tell me what the blue area percentage is. Well, you take 0.1908 from what?
280.
Not 280. What's the area under the curve? 1. 1 minus 0.1908. 0.1908. And the blue area is 0.8092. Now, I want somebody to tell me, what is the percentage or the probability that the baby will be born less than 280 days? You got an 81% chance, or a 0.81 probability, or 0.8092 probability, or the area, the blue area is 0.8092. And that's how you do that one. Now, is there a little bit redundancy on this homework question? Yes, there's a little bit. This homework question, I want you to read the question. It says, write the yellow in two different ways. The proportion of human pregnancies that last more than 280. Oh, I'm sorry. I thought it meant you were going to have a baby. Okay. Last at more than 280 is 1908. And here, the probability that a randomly selected human pregnancy lasts more than 280 days is what? 0.1908. Do they say the same thing? Yes. But they're trying to get you to learn something here. They're trying to get you to learn how to read this right here. They're trying to get you to learn how to read the right side and read the left side. Right side, left side. Left side is less than 280. The yellow side is more than 280. Okay, let's do the second one. The area between what? 285 and what? 305. So I'm going to do 285. We're going to do this in orange. 285, 285, 285. 285 is right here. That's 285. And 305 is right about there. And they want to know, and they say that the probability is 0.1101. 0.1101. Point 1101. So tell me what that means. Somebody put in layman's terms what that means. What does that orange area mean? That your pregnancy is going to last between, or there's a what % chance that your pregnancy is going to last between 285 and 305 days?
Is it 11% chance?
11.01% chance. Or, I'm going to write this down for you. There is a 11.01% chance, a 0.1101 probability, or 0.11 probability that your pregnancy will last at 285 to 305. There is an 11.01% chance, or a 0.1101 probability, or a 0.11 probability that your pregnancy will last between 285 and 305 days. Or I can say the area between 285 to 305 days is 0.1101. So that's another way I could say it. But all three are saying the same thing. Now, you're going to be doing some other stuff in 7.2, but this is kind of getting you used to doing these big numbers down here when you're used to doing 0 and 1. They're kind of getting you ready for it, because this ain't what you're doing in 7.2. You're getting used to it, but it's not what you're doing. Okay? Next question. Now, this is what we went over the other day, I think. This next question we went over. This question right here, this is 4 test questions. 7.2, 5/2. 7.2, 5/2. There's 4 test questions here. There they are. So I'm going to blow it up. There's 4 good test questions right there. Determine the area under the standard normal curve that lies to the left of those 4 numbers. And I'm going to draw 4 different curves. And I think I just ran out of my double curves. Yep, so I have to use my big curve for the second 2. I ran out of my double curves. All right, I'm gonna write them down so I'll have them, and then I'm gonna switch over to the. Where is my? There we go. All right, 1.65. 0.1101. Z is equal to 0.01. Z is equal to 0.94. And Z is equal to negative 0.49. Okay, so the first thing I'm going to do is I got to draw a line on these. These graphs didn't have a line under them.
Gmail.
All right. So 1.65. Where is 1.65? 1.65 Z is equal to 1.65.
Excuse me, Hubert, I have to go back on the floor.
Okay. All right. Well, just watch these two videos.
I will. Thank you.
Okay. Bye-bye.
Bye.
1.65. Oh, that's almost time for. Okay, we'll finish this one. 1.65. There's 1.5. So 1.65 is going to be right in there. And I'm going to highlight that area in orange. So they want to the left. Okay, and what is this arrowhead called down here? What's this arrowhead called right here?
Unusual.
No, what's the arrowhead called?
Negative infinity.
Negative infinity, but we can't put negative infinity in the calculator, so what are we going to use? Negative 9999. Because we can't use negative infinity in the calculator. We can't use positive infinity either. So this arrowhead up here is called positive 9999. Because we can't use negative infinity in the calculator. So, which way do we read? Left to right. So we're going to do normal, CDF, parentheses, 9999 negative to 1.65. But before we do that, let's use the empirical rule to add up what we think it is. So 0.15 by the empirical rule, we estimate 0.15, 2.35, 13.5, 34, 34. 1.5 would be 16, or no, I'm sorry, 1.5 would be 6.75. So I'm going to say 8.75 because it's just an estimate. Now, if you add all those up, let's see, 75, that's going to be 25, that's going to be 60, 75. I think we've brought one up here. I think when we did that. 75, that's 20, yeah, I'm pretty sure. All right, so that's going to be 8 and 8 is 16, 19, 20, 22, bring you 2, 3 and 3, that's 9. I say it's going to be around 0.9275. 0.9275 by the empirical rule. So let's see. Let's take our handy dandy calculator and do normal CDF. So that would be second bars. I don't know why I do that fast accuracy every time I do it. Second bars, normal CDF, negative 9999 to 1.65, and enter. Now, if you got an older calculator, that's the way you type it in, negative 9999, comma, 1.65, close parentheses. You don't need to put the 0 and the 1. Just close parentheses and hit enter. 0.9505 is your answer. 0.9505 is your accurate answer. Okay, 0.01. Well, 0.01 is just a shade over 0 to the right. Not very much. Very, very close. Okay, so the blue is 0.01. So somebody tell me, without thinking too much, what is our answer going to be close to? What is 0, people? What is 0 by the empirical rule? Oh my gosh. Please tell me y'all know. Remember the fuel gauge? What is 0?
Oh, is that it's to the left side? Is that what you're looking for?
Fuel tank. What is this?
That's half.
Half. So this is 50%. We're just shade over 50%. So I'm going to say 0.5020. So by the empirical rule, I'm going to guess 0.5020 because I know it's just a little bit of shade over that 0 line right there. So it's going to be just a little bit over 50%. So let's add them up. I mean, let's do normal CDF. Normal CDF. And if you got an old calculator, negative 0.999, or negative 9999, comma, 0.01, close parentheses if you got an old calculator. So I'm going to take my handy dandy calculator and I'm going to hit second. Oops. Not going to hit that. Second quit now. Please. Second. There we go. And I'm going to change my 1.65 to 0.01. And hit enter. I got 0.5040.
Yeah, that's what I got.
And notice I got 0.5020 because I was just using the empirical rule, and that's a good check because we hit right in that area. All right, now you do the last two. I'm going to let y'all do the last two on your own. We got to hurry. Oh, well, let me just do them right quick. All right, so 0.94, I'm going to do that in pink. 0.94, there's 0.94 right there. And I'm not going to do the estimation, I'm just going to do the normal CDF. So I need somebody to type in normal CDF from negative 9999 to 0.94, sorry. 0.94, let me put that right here. I'll say, just guessing without writing everything down, I would say probably that's 3/4 of the way. So 4, that'd be 8. So 8 from 84 will be 76. I'm going to say around 0.7600. What did y'all get with normal CDF?
I got 0.8264.
Okay, I was way off. 0.8264. Normal CDF, parentheses, 9999, negative, comma, 0.94. And then the other one says, and I'll use a blue. Let's see, can I use a blue? I guess I can. I'll use, yeah, blue. And that's 0.49 negative. Negative 0.49, there's 0.5. So 0.49 would be a little bit less than 0.5. So that's going to be this area right here. So normal CDF negative 9999 to negative 0.49. Somebody give me that number, please.
I got 0.3121.
And that's how you do those problems. So now y'all should have enough to go on to work on 7.1 and maybe start a little bit on 7.2, not much, because I still haven't covered the good stuff of 7.2. Those of you that I called their name out on the roll, go ahead and leave. I'll look on the left, see who's left that came in late, and I'll check you off the attendance. So those of you that I've already called, you can go ahead and leave. People that I didn't call, let me go ahead and pull y'all up again.
Bye, Hubert. See ya.
See ya. 120, 23. Hey, bye-bye. Jacob and Deese. Jacob's here. And Deese. Deese didn't come in. Jones came in. And that's it, I guess, because everybody else left. Okay, y'all go ahead and leave unless y'all eating breakfast or went back to bed. In that case, I'll have to force you out, but I'm going to give you at least 5 or 6 seconds to leave on your own, so I won't have to force you out. So I'm going to give you a couple more seconds. Couple more seconds. Can you make it? And I guess Miss Hooper and Jones, I guess y'all were eating breakfast or went back to sleep. Just wanted you to know that I know that you've left your computer. So I'll go ahead and